Okay. So now we're going to move. Now, one other new thing we're going to talk about are way over here at the end, part correlations, or you'll also see these referred to as semi-partial correlations. Or you might hear people talk about part and partial. They're different. We're not really going to talk about partial. But we will talk about the part. We will talk about the part or again, semi-partial, same thing, correlations, because you will see them discussed a lot, though maybe not called that. You may see them called as, or people talk about them as the unique variance. When they talk about the unique variance, they mean a part or semi-partial squared. And what particularly if you square the semi-partial correlation, it's the unique variance related to just that instead of trying to, you square it and we get the variance in the outcome that's related to that predictor uniquely. It's the variance that's only, the variance in the outcome that is only related to that variable, to that predictor. It's mathematically, we're going to see, it's as if you entered that variable. It's the effect for that variable as if you entered it last in the regression model. It's that unique effect of the variable. So let's take a look. So the unique effect of mom's education in model 2, because we're still at that second model stage. We take the 0.311 squared, we get 0.097. 9.7% of the variance in grades is related to mom's education and only mom's education. And for school quality, we take the 0.117 squared and we get 0.014. That's the variance that's only related to school quality and not mom's education. So it doesn't overlap with mom's education much, at all, not much, at all. The F-test for these is, the t-test for those is the same t-test as for the regression coefficients. Remember there was that whole Costco little video, right? It's one-stop shopping. That's the same as that. Visually, this is what it looks like. Now notice this gray overlap area is that part that's related to both school quality and mom's education. So we know the total effect of mom's education was 0.128, right? But the unique effect just over here on its own is 0.097. And again, this hasn't changed because remember when we entered school quality, we already took out all of the effect of mom's education. So it's still the same 0.014 because it was the last variable that we entered in the model. Right? And that's the effect that's when we enter something last, it's going to be the piece that's not related to anything else. So that's why the part correlation squared is the same, it gives you the same effect size, the same r squared, or change in r squared, as if you entered that variable last in the model, because it's controlling for everything else, which is entering something last in the model. You're controlling for everything else. Everything else has already got those effects removed. So here, again, kind of the two unique effects. So it's kind of more information. The total variance is still equal to 0.141, right? The total shaded area is still equal to 0.141. But now we're able to see of that 14.1% of the variance, 9.7% is unique to mom's education, 1.4% is unique to school quality, and what is that? About 3% is that overlapping gray area. Or is it 2? Yeah, 3. Okay, ish. Questions? Now the final model, step 3, now we're adding study hours. So our total sum of squares is exactly the same. Total degrees of freedom is exactly the same. The sum of squares regression has now gone from 29.5 to 30.397. So it's gone up because we've added another variable. It doesn't seem to be adding a whole lot, but it's adding something. Our number of variables have gone from 2 to 3, so the k, our degrees of freedom regression, has gone from 2 to 3. We calculate our mean square is exactly the same. This divided by this is 10. This divided by this is 0.45. 10 divided by 4 gives us the 22, right? Exactly the same all the way across. Model 3, so the total model, this is the effect of all 3 variables as a team, is statistically significant. F with 3 and 396 degrees of freedom is 22.463. P is less than 0.001. So that total model altogether is still statistically significant. The total model altogether accounts for 14.5% of the variance. 0.145 is our R squared. That's the effect of mom's education, school quality, and study hours as a set, plus whatever indirect effects they may be having with other variables, that are not in our model. Just kind of good to remember there's other things out there that they might be working with. Our F change, we calculate exactly as before. Our change in our R squared change goes from, it's now 0.145. It was 0.141. So the R squared change is 0.004, or 0.4% of the variance we've increased with study hours. Our F change, we do exactly the same formula. I'm not going to just sit up here and repeat it. And we get an F change of 1.875. Plugging in the old k, new k, change in R squareds. Notice that the variables have gone from 3 to 2. Right? Well, you know what I am going to say. So the R squared new, 0.145 minus R squared old, 0.141. The k new is 3. The old k, our old number of variables, was 2. So it's 0.145 minus 0.141 divided by 3, the new number of variables, minus 2, the old number of variables, divided by 1 minus the new R squared, 0.145, divided by n minus our new k, 3 minus 1, because it's 1 minus 0.145, divided by 400 minus 3 minus 1 is 1.875 is our F. The degrees of freedom is 3 minus 2, our change in, the degrees of freedom is the change in k, 3 minus 2, or 1, and n minus k new minus 1, 400 minus 3 minus 1. So the degrees of freedom are 1 and 396. It's right here, 1 and 396. F with 1 and 396 degrees of freedom equal to 1.875 has a p-value of 0.172. So that doesn't mean the overall model is not significant, right? The overall model was significant. The set of 3 variables was significant, right? The group of all 3 is statistically significant, with an F of 22.463 and 3 and 396 degrees of freedom. The effect of adding school quality was not significant. Different question. An F with 1 and 396 degrees of freedom is 1.875, P is 0.172. So 2 different questions. kind of verbally, we can summarize that as the inclusion of study hours accounts for an additional 0.4% of the variance in grades, which is not statistically significant. F with 1 and 396 degrees of freedom is 1.875, P is 0.172. So that reflects the idea that the variance in grades that are uniquely related to study hours beyond school quality and beyond mother's education is only 0.4% and not statistically significant. From a Venn diagram, this is what it looks like. Right? Now we're back to the kind of, here's the 0.128, the 12.8% that belonged to mom's education, because it came first. It planted its flag. Then 1.4% or 0.14 is the R squared related to school quality in our causal model. That's when it planted its flag. So it beat out any overlap it had with study hours is already gone. It's been taken by school quality. And then finally, study hours has that little bit of sliver up there at the end, 0.004. If you add those up, our initial R squared when we had grades in mom's education was 0.128. We added the 0.014 for school quality, and we add the 0.004 for study hours, the change in R squareds for those, right? So we start with the initial R squared with mom's education, add the change in R squared with school quality, add the change in R squared again when we subsequently add study hours, we get 0.128 plus 0.014 plus 0.004 gives us 0.145, which is the total R squared. Again, they all kind of add up to the total within rounding.